This is the Fusion 360-CAM tutorial for the TCOSE-07 part. So you should already have this part modeled. We're going to go to our data tab and I'm going to open my TCOSE-7 part. And then go ahead and close the data panel. It gives you more screen to work with. So it has a couple bores here, a profile, and a small diameter hole for a press fit for a pin that needs to go in there. And that pin is designated as 1.5 millimeters, which is very close to 1/16 of an inch. If you were choosing to swap everything out for standard pins, you could open up that hole size and make it 1/16. Okay, now that we're in the design workspace, we need to change to the manufacturing workspace. We're going to highlight setups. This is going to be a 2 setup part. We're going to machine everything you see in the top view of the part and then come down and have a fixture that will machine just the hole, drill the hole. And the outside part will be already established. Okay, so let's start. We're going to go to setup and we're going to type new setup. And this window by default pops over on the right here. We're doing milling, and our material here, we're going to set our material size first. So on the sides offset, like our other stuff, let's put a 1/2 inch. It's probably way more than we need, but it'll give us some clearance to clamp on. You could, on a part this small, we could probably do a little bit less. And on the top offset, we're going to put it at 0 because it's 3 millimeter thick stock. And I think we can get brass in that thickness. Alright, so we end up with a stock size of about 1.4 by 1.9. So if you're cutting it on the saw, that's what you would need to cut. Now we're going to go back to the setup window here, and just out of habit I try to put the long direction along X on a vertical mill because that's the longer travel of the machine. This part's so small it's semantics, but we're going to change this from model orientation to select Z-axis, which is going to be the top of the part, and then our X-axis. Our X-axis, we're going to actually pick what's called out as the Y-axis, and then that'll flip our X-axis in that orientation. Now for our actual origin, we're going to use a box point, and we're going to use a stock box point, and we're going to select the top left corner. We're going to be consistent with that on a lot of these parts. Okay, now we're going to go over to the post process, and we're going to use a naming convention based off the part number. So this is part number 07, and this is going to be program 1. So 0701. We're going to type operation 1 into the program comments with a work coordinate system of 1. Okay, that should be it for the setup. Hit OK, and we should get setup 1 over here. Okay, so we've brought in our model, we've created our setup. Now we're going to start cutting. And our strategy on this is going to be to cut this with the smallest one. It's 4 millimeters, a little too small to cut with an 1/8 inch end mill with interpolation. And we don't want to set up a drill bit just for that. And this is larger, so we can either cut that with the 1/16 or the 1/8. I think I'm going to opt for the 1/8 inch end mill though, because it's large enough. So let's go to 2D contour, and we're going to select. We're going to go to the TCOSE library. We're going to select tool number 5 for 16th inch flat end mill. Select OK. Okay, 4,000 RPM, And our cutting feed rate, I think we calculated it at about 7 or 8. So let's do 8, 8, 8, 4, and 4 for ramp and feed rate. Okay, let's go to geometry. We're just selecting the bottom of this hole. Double check the arrows on the correct side of the part, or correct side of the hole. The next tab, heights, we're going to leave all these at default. We're going to move on to passes. On passes, we want to do wear compensation. And then we're going to select roughing passes, which will make the finish step over appear. And we'll go at 5 thousandths. Now we're going to go down to roughing passes. We're going to do a minimum step over of, let's say, 0.04, and smoothing the deviation of 4 thousandths is fine. We're going to do one step over. We're going to do multiple depths. We're going to do step downs of 0.02, 20 thousandths. And we're going to do one finishing step down. Let me hide some of this. And our finishing step down, instead of that big long number, we're going to put in 0.005. Okay, and we're going to finish at final depth. We're going to rough the final. We're going to use even step downs. We're going to ignore the rest of these boxes. They don't apply for a single feature. No stock to leave. Our smoothing, we do 1 on 4 thousandths, so we get a nice round hole. And now we're going to the linking tab. We'll just leave, if you have 60 thousandths or so, we'll leave those lead in and lead outs at default, but we're going to take away the vertical lead in. And then we're going to hit OK. So we should have several roughs down in Z and then a final finish pass around the outside edge with a real small lead in and arc. And we output cutter compensation, so if the machinist needs to bump that a little bit larger, they can. Next operation. We're going to go to contour again. Select. We're going to select the TCOSE library, and then we're going to select tool number 17, which is the 1/8 inch flat end mill. And select OK. So we should have on that tool, it should auto-calculate everything on this first page. Now I made a mistake when I made the tool, forgot to set the ramp spindle speed to 5,000. But you should have 16 inches or so a minute and 8 inches a minute plunge rate. Okay, our contour selection is going to be just the center of this. And you want to make sure the arrow is on the inside, which it is. And we're going to go to heights, and we're going to leave all these at default. Move the passes. We want wear compensation. And then we're going to skip on down and select rough passes. And we're going to set a step over 0.005 like we did with the 1/8 inch end mill. And then we're going to come down to maximum step over, and we're going to put in 0.1, which is about 80% of that diameter of that cutter. Smoothing deviation on the roughing can stay as it is. We're going to do one step over. We're going to do multiple depths. Let's hide the passes here. And our maximum roughing step down, let's do 0.03. And we're going to do one finishing step down, and that finishing step down, we could do a 5 or 10 thou, but we'll do 5 to be consistent. And we're going to finish only at final depth, and we're going to use even step downs, leave the rest of these at what they are because they're irrelevant for a single feature. And we want to select the smoothing because we want a nice finish on that arc. The next page, all this stays at default. I think we can leave all these other ones at default, except we're going to take out that vertical lead in. We don't need that. And then we'll hit OK. Processes, we should get several circular moves with a finish cut at the bottom. We're going to do the final step with this setup, final routine, which is going to be to profile the exterior of the part. I'm going to copy this toolpath and we're going to duplicate it. So right click on it, press duplicate, and it'll create a second one. We're going to edit that toolpath. The tool stays the same. The geometry does not. We're going to select the outside of the workpiece. Select on the front so that hopefully you got it starting where the operator is. And you can see the arrow is on the outside of the part like we want. On the heights tab, we are going to change something here. We're not going to go all the way to the bottom. We're going to leave 10 thousandths of flash at the bottom. Actually, let's make that 5. I'm going to leave 5 thousandths of flash at the bottom to be removed. Hopefully we can break it off like foil. So we want a positive number in there. So the end mill won't cut all the way down through the material. The rest can stay at default. We're going to the passes. We can leave pretty much all of this at default. And go to the linking tab and leave all this at default too. It worked on the last one, so let's select OK. So we get our small arc ends where we selected and roughing and finish passes. So here we finished setup 1, which was to profile all the part. Now we need to set up 2, which is going to drill this hole. It's going to be held in the machine a different way. I would probably make a fixture that has pins that locate this in a vertical orientation. So we're going to go to setup and we're going to create a new setup. Now we don't have any stock. It's already been milled to size. So our stock is the model itself. So what we're going to do is go to the stock tab. Okay, so we're going to pick from solid, and then we're going to, in the solid we select for the stock is going to be the body of the part. So now we're going to go back to setup, and we need to orientate this axis. Okay, so we're going to do, so the model orientation, we're going to do select X and Y axis. So our x-axis is going to be here. It's already at the right place. And then our y-axis is going to be here. All right, so that flips our orientation. Now we're going to go to a stock box point. It didn't select what we initially wanted, but popped to the center. So we're going to hit stock box point and select box point. And if we assume our fixture is going to be maybe connected to a vise and facing the operator, we'll put the datum for Y on the back side of it so we can indicate in on whatever that fixture is for the Y-axis. So we're going to go to post-process and we're going to call this program 07-02. It's the second program for the -7. We're going to call it operation 2. And work coordinate system 1. Okay, we have setup 2 ready to go, and we're going to drill this hole. We're going to drill the hole with a 1.5 mm drill bit. We're going to select the TCOSE library, and we're going to select tool number 11 for the 1.5 mm drill bit. And select OK. You'll see the decimal equivalent here in the description. Okay, spindle speed should be set. We want to go about 6,000 RPM, 8 inches a minute. Our retract rate, 40 is fine. That's when it's pulling out of the hole. We're going to go to geometry, and we're going to pick the very bottom hole because it's interrupted. Now we're going to go to the heights tab. And this is going to be important we set these correctly because we've selected a hole that has the top way down here in the middle of our part. So what we want to do is we want to set our retract height based off our model top. And then we want our feed height is fine to be off the top height, but our top height needs to be model top. And that's going to shift this cyan colored plane up. Okay, so that's where we're supposed to start feeding. Now, and our bottom height is the bottom of the hole. Just fine. But we want to put in drill tip through bottom, so we make sure we get a hole that's the correct depth. Alright, so we're going to do all rapid movements above this green plane, and then when it gets to this blue plane, it's going to start pecking and drilling through. Okay, so we're going to go to our cycle, and we want this is a deep drilling with full retract. That's the perfect application for it. Soft material with a very small drill bit. You need to clear all the chips. So our peck depth, we're going to set that at, let's set that at 0.02. And then we're not going to use reduction, and we'll leave our minimum peck at the same. But okay, there we go, we have it. Okay, so it should come down and drill that hole, little tiny hole. So now I want to come back and I want to rename some of these. We have two contours here. This first contour here is labeled 3 on my example. It's 1/8 inch end mill. We're going to put L bore for large bore. So that's just a note so we know what it is. And then contour 4, we're going to change that to S bore, which should be this S bore, which is the small bore. Okay. And then this last operation here was this profile. So it's the profile of the part. And that way it'll show up in the code. We only have one operation on setup 2, and it's a drilling, so I think that's descriptive enough. Alright, so at this point you're going to need to, you can simulate. I always recommend simulating. Let's go ahead and do that for setup 1. So let's go to simulate. We want to show the stock, and let's show it do its business. We're cutting our first hole with a 1/16 end mill, cutting the large bore with an 1/8 inch end mill, and then we're going to come around and profile around the outside with our 1/8 inch end mill. Those are all roughing cuts, and then it does a final finish cut. Okay, so we're done with simulating that one. Let's go to setup 2, as if it were on the machine. It would be this orientation here. And we'll do a simulation of that one. Okay, so our material is the part itself. And let's play. Okay, there we go. The next step is to make your setup sheet. and select your folder. And your setup sheet should look something like this. Alright, for setup 2. And for setup 1, you want to make sure you move the model before you do the setup sheet, so it looks like it would be on the machine with the origin displayed and setup highlighted. You're going to create your setup sheet and it should look something like that. Remember to review this for red flags or RPMs and feed rates that seem out of whack before you post-process. Then you're going to post-process, and we're going to post-process that for the HAWS pre-NGC. Okay, hit post. Save it at a destination, and you should have a text editor open it up. Okay, so you'll need to submit setup sheets and programs for both setup 1 and setup 2 of this part. All right, I'll catch you on the next one.